Right, conditional probability. Okay, so basically, before I explain what that is, it's best if I explain actually through a question. So if the question says, in a bag, there are 3 green, 4 blue, and 2 pink cards. If I take out 2 cards, what is the probability the second card is green if the first card was green? So what they're saying is, if I chose a green card in the beginning, what's the probability of choosing a green card now? How many green cards are there?
2.
2 out of what? Count them. 1, 2, 3, 4, 5, 6, 7, 8. Yeah? Yeah? 2 out of 8?
Yeah, which is 1/4.
Yeah, that's all it is. What's the chance that the second card is pink if the first card was pink? So that means for my second pick, the first pink card is already chosen. Okay? So what's the chance of you picking a pink card now? 1 out of 8. Okay? So that's what conditional probability is. So basically, something has already happened. What is the probability of something happening after they've told you what has happened? Yeah, does that make sense? What's the probability that the second card is blue if the first card was pink? So what do I need to do in this scenario? With a diagram, what do I need to do physically? Take out the pink card, and now they're asking you what?
What is the chance?
Yeah, how many blue cards are there? So what is it?
4 out of 8.
4 out of 8.
Uh-huh.
Yeah, that's all it is, okay? So it's just about reading the question carefully. All right, same concept here. So 2 dice are rolled. I've written all the outcomes possible that we've done last time. Yep. Given that the sum is 9, so that's the condition. All right? Find the probability that one of the dice shows a 4. Which combinations give me a sum of 9?
3, 6, 4, 5.
Yeah, that's right. So 3 plus 6 is 9. Yep. 4 plus 5 is also 9. 5 plus 4 is 9. 6 plus 3 is 9. Any other 9s? No. How many of those combinations has 4?
2.
Yeah. This one has a 4. This one has a 4. So there are 2 out of 1, 2, 3, 4. Yeah, makes sense? Okay, let's do the same thing here. Given the same condition, if the sum is a 9, so looking at these numbers again, one of the dice shows an even number. Let's have a look. One of the number is an even number. Look at this one. Does it have an even number?
Yes.
Yeah, 6 is an even number, so that's one of them. How about the next one?
4.
4 is an even number, so this is one of them. How about this one?
4.
4 is an even number, so this is one of them. How about this one?
6.
Yeah,
1. What?
that's right. What she's saying is, see how all 4 of them has an even number? That means the probability is 4 out of 4, which is 1. Yeah, makes sense? Yeah. Given that one of the dice shows an even number, given that one of the dice shows an even number.
If you have a word only, it makes explicitly only one
Yeah.
dice.
Yeah, that's what I feel like. If the question was given that only one of the dice shows an even number, sure, only one die is an even number. But if that word only isn't there, it just says given that one of the dice shows an even number.
You just need one dice that shows an even number. It could be 2, but it has to be
Yeah, let's interpret it like that. Yeah. So given that one dice is an even number, that means you can have 2 dice that's an even number for both. Okay, let's go with that. Find the probability that the sum is even. Okay, before I do that part, let's just circle all the combination where one of the die is an even number or both of them. Okay, let's go through it all. One, they're both odd. Okay, I'm going to do it in, where's my red pen?
I think if we just go with both odd, it would be faster. Yeah.
Both odd?
Yeah.
All right, I'm going to cross off all the odds. Cross off everything that we don't want.
1, 1, 3,
3, all right, so we're going, 3, 3, 5, 5, because these are the combination we don't want.
3, no, 3, 1, 3, 1.
3, all right, 3, 1. Oh, it's like a game.
5, 1.
What?
5, 1.
5, 1. 5, 3.
Yeah, we're done.
Yeah, so there are 36 of them here. So all the combinations where we have an even number, or both of them being even, that's 36 take away 1, 2, 3, 4, 5, 6, 7, 8, 9. 36 take 27. Got the answer, or almost got the answer. All right, almost. All right, so out of 27. Now let's have a look at this part of the question. Find the probability that the sum is even. So let's, out of all of these, how many combinations add up to an even number? So, for example, obviously, this is 3, so that's not it. That's a 5.
Even. So the ones that are both even are the ones that have the sum of even numbers.
Yep, so like for example, the 2 evens, like 2, 2, that's a 4, so that's one of them.
4, 4.
Yep, 4, 4. Yep.
4, 2, 6.
6, 6.
Oh, so right. So you're saying if both of the numbers are even, it's definitely an even number.
Even not even because even.
Good, good, good. Keep going. What else is there then? 4, 2.
4, 6.
4, 6.
6, 2.
Right, 6, 2. 6, 4.
6,
6, 6. What's the answer then? How many is there?
9.
Yay! That's what we wanted. That's the answer at the back of the book. All right, we got it. Good, good, good. So, wow, probability. You really got to read the question carefully, as you can see.